Hello, my name is Justin Patton. I'm the director of the Auburn University Rfid Lab, and I'm going to talk to you today about Rfid and Auburn University. So, a little bit of background talking about technology innovation. In 1980, there were two big things in the news in terms of new technology. One was the first space shuttle launch. The space shuttle didn't launch its first mission until 1981, but there was a lot of prep in the lead up in the last few months of the year. And there was a lot of hype in the news. The other thing that happened is the retail barcode scanner adoption really took off across the United States. We started to see retail barcode scanners in checkout lines from grocery stores to Walmarts to everywhere. That was the breakout year. Now, in terms of technology, we typically think about things like space shuttles and the space program as being the height of technology. But a lot of times we don't necessarily fully understand what they do from a dollar value perspective. It's very hard to sit down and say, here is the specific ROI of the space shuttle, because I'm not sure how the space shuttle directly influences my everyday life. It influences it many ways. We have many new products. We have many new things that we get from the space program that we've learned. But it's not something that we can sit down and say, this is how it saves me X amount of time per day or whatever it may be. When on the other side of the fence, when we talk about retail technology, specifically the barcode scanner, it is very easy to draw a direct comparison to how this technology benefits us. It's very simple to say, okay, this is how much a barcode scanner costs in a store, and here is specifically how much time it saves, because we can measure how much time it takes us to check out with a barcode scanner versus the amount of time it would take someone to check out by keying all the things into a register. We can also directly measure how accurate a barcode scanner system is for checkout versus some of the mistakes and errors you may make without a barcode scanner system. So it's much simpler to draw that direct cost benefit from something like a barcode scanner in a retail store. But because of that, we often see it as something that is not necessarily the height of technology. Because we've seen barcode scanners every day, because we use them every day, people don't necessarily think of them as being extreme high tech like we would something like the space program, because we don't understand the space program as well. It's harder to draw those immediate benefits. And the reason that I'm saying all this is because whenever we talk about a new technology like RFID, especially as it relates to the retail world, that technology cannot be a space program. It can't be something that we feel like is for the good of everyone or will have some more benefits down the road. It has to be very specific. It has to have some type of an immediate benefit. It has to have some way we can show on paper almost from the start how it's benefiting these areas in order for it to be broadly adopted. So as I go through this and talk about RFID today, I want you to think about this more like a barcode scanner. This is something that is going to be very, very specific, that we're going to explain why it helps rather than it be much broader. We're doing this because it looks cool or because we think that there will be more benefits later. So the RFID Lab itself, we study the business value of RFID technology. We have a space in Auburn. It is about 13,000 square feet. We're on the corner of Glenn and University in the HR building. It used to be a Bruno's grocery store, so we were lucky enough to get a lot of space back there in the back. We have about 15 students that work there in the lab. And we focus heavily on physical and disruptive technologies, including a strong change management component. All we're saying there is that we're looking at physical technologies that influence the world around us, and we're looking at technologies that would change the way that we interact with things. RFID would change the way that we physically do inventory. It will change the way we count things. It may even change the way we check out or shop in a store. And we have to understand how the people are going to interact with that new technology as well. From a business case perspective, we don't do anything in the lab that we can't justify to someone who's going to purchase it and use it. So we have to help establish the specific business value. Again, we don't do anything because it's fun. We do it necessarily because it's going to lead to a benefit for these organizations. And we tend to focus on that 1 to 5 year adoption window. So these are things that are going to be adopted in the immediate future. And then we do a lot of implementation support. So people and companies that have started out with RFID will help them understand and when they run into problems, how to resolve them. So what I'd like to do is tell you a little about what RFID is, and we made this video um, not too long ago with my son that kind of shows a little bit how we use RFID in a retail store, and it shows how RFID works versus a traditional barcode scanning system. All right, and we're back from the video. And the technology itself that you just saw consists of a few different components. There's a reader, and there's an antenna, and there's an RFID tag. And within that RFID tag, there is a RFID microchip. It's a very small chip. It's the size of a grain of sand. And there's an antenna that attaches to that goes around that chip. We're specifically talking about UHF RFID. There's many different flavors and types that you'll see out there in the world around you, but UHF is the type that's longer range and most typically seen in retail stores. These RFID tags are usually a few inches long. An RFID antenna puts out an RF field, which you can see by kind of the red circles there. They light up the tag, so it powers the tag, and then the tag responds back with its identity number to the antenna. And there's a reader unit that's collecting all of this information and providing it to whatever software we have on the network. RFID readers come in a lot of different shapes and sizes. On the bottom right, you can see a handheld reader that's a Bluetooth device. It can connect to an iOS or an Android device like the iPhone that you see on there. And that would be something that you would carry around and scan things with. On the top left there, you see RFID portal. So those gray things on the sides of the dock doors, those are actually scanning the items that are going through those dock doors, and those are static RFID scanners. RFID tags come in many, many different shapes and sizes. Some of these tags are older and some of them are newer. There's a nickel in there so you can see the approximate size. But we have different shapes and sizes of antennas on the RFID tags because we put them on different types of products. The physics of RFID is such that metal causes reflection of radio waves. You probably experienced this in your everyday life. Sometimes you'll get into an elevator with your cell phone and you lose reception because you're walking into a metal box, and metal shields radio waves. The other issue we run into frequently is water. Water absorbs radio waves. That's why we use sonar on submarines and not radar. So if you have products that we're putting an RFID tag on that have a high metal content or a high water content, different types of antenna structures work better for those items. And we do a lot of experimentation at the lab to figure out what is the best. In terms of applications, there are many, many, many applications. Retail inventory is one that we've talked about already. NFC phones. You might have used Apple Pay or some tap-to-pay applications in the past. Automobile systems, if you have a new vehicle that has the key that you just keep in your pocket with a key fob and the starter button. Toll roads are a lot of times RFID. Access passes that get you into buildings. You probably stayed in a hotel in the past where it uses some type of an RFID tag within the room key to get you in the room. You can see on the screen there, Disney is a big user of RFID on the wristbands to get in the hotel rooms and the parks and other things. Anti-theft tags, we use them sometimes on items in the store for shoplifting and anti-theft. Airline baggage tags. Last year, Delta started putting RFID tags in all checked luggage. IATA, which is kind of the International Standards Organization for airlines, has asked that all airlines use RFID tags on all luggage by 2020. Aircraft parts, we use it for maintenance history. Sports player tracking. Many of you have watched the NFL. where they have new enhanced stats. So it'll show things like player separation or player position on the field. The players actually have RFID tags in their uniforms that we're using to track them in real time. And this EPC symbol that you see here in the middle of the screen, this is a consumer notification. So next time you buy an item, take a look on there at the label, and if you see that EPC symbol on that label, then that typically tells you that there's an RFID tag in that item. The tag is harmless. It doesn't transmit. It has the same information as the barcode that's on the outside of the item, along with a unique serial number for that item, and is typically used by store systems for inventory control. These are a lot of the companies that we've worked with in the past using RFID in a lot of different applications. Some are solution providers, some are aerospace, some are retail, whatever it may be, but these are some of our partners here at Auburn that we've worked with. So I'm going to tell you a little bit about the history of RFID, especially in supply chain. In 2005, we really started using RFID in the distribution center and in the supply chain. So we really thought of it as a case and pallet level technology to help us with shipment receipt and accuracy and so on and so forth. But in 2007, we refocused that industry initiative to be more on item level items in a retail store. What we found is there are some good benefits in the supply chain, but where we had no data visibility in the past was actually on the retail sales floor itself. Most stores can't really tell you the difference between items that are in the back room versus items that are in the store shelf, because there's no type of a system that automatically captures those items as they move around within the store or as they pass through the doors. Someone has to scan them, and it takes a lot of time and effort to scan items on a retail sales floor with a barcode system. It takes so long that in a lot of department stores, they only do a full store inventory maybe twice a year with a barcode solution. With an RFID solution, we can do inventory every day. Some stores use it once a week. Some stores use it every few weeks. But the point is, we can take inventory much more frequently, much more accurately. So you as a shopper, when you go to that store, you're going to be more likely to find the items on the shelf that you're looking for. If the item isn't on the shelf that you're looking for, the store inventory is going to be more accurate, so they can tell you whether they actually have it in the store or not for you to go look for. And it also helps the store stock the things that customers want and not stock the things that customers don't want. So you don't end up paying more for a product as a consumer just because you're subsidizing all the items in the store that didn't sell that people don't want. And that also leads to less waste in the supply chain. We're not making and shipping tons of items through that people don't want to buy and then end up paying for that through the products that people do want to buy. We're trying to right size or understand what consumers want, and less waste, less clutter, faster shopping, more accuracy, many benefits. And that's been the focus from 2007 until now. In 2018, because we have seen so much broad proliferation among the retail stores, we've started moving back upstream into the distribution center and supply chain with RFID again. It's coming full circle. So whatever happened to data exchange, this is one of the things that we talk about a lot. Most retailers are receiving RFID tagged items blind from suppliers. What that means is that if I am a retailer that's using RFID in my store, let's take Macy's or a Target, for example, when they get those RFID tags into their distribution center to put it in their store, that's maybe the first time that they've seen that RFID information. They're not asking their product manufacturers that are making RFID tags or making items that they're putting RFID tags on to go back and send them a list of the serialized RFID numbers to the store when the shipment comes in. They're just saying, put the tag on there, we'll scan it and use it when we get it. So a lot of these product manufacturers are putting the RFID tags on in the manufacturing facility, wherever that may be. A lot of times it may be internationally, down in Central America or over in Asia. Then when those products are shipped and they're traveling internationally across the ocean or over the air to the U.S. and then moving through a variety of DCs here in the U.S. and actually getting to the store itself, we have this RFID tag with the serialized data, and many times we're not leveraging it. We're only looking at it when we put it on at the source, and again when we scan it right before it leaves the store. What we're doing is we're trying to move back to where we're actually using it all the points in between, and then that really helps with the cost of the item. Most people think of the cost of items, especially for apparel items, being in the material and the fabric and things like that, when actually the majority of the cost of most items you buy in the store is more from the logistics. It's the cost of actually getting it there, that more so than the cost of actually manufacturing it itself. So when I said this earlier, and I know this is a little bit complex, but this is a model of the supply chain. On the far left here, you'll see the factory itself, and where we circled in red at the factory is a lot of where we put these RFID tags on there. Those items then will go to an international port, which then will go to a U.S. port, which would then travel into the supplier distribution center. From there, we would go over to the retail distribution center and then back onto the retail store. So again, we have circled in red where we're using RFID. So we've bookended the supply chain. What we want to do is go back and start filling in all of these use cases and all of these nodes along the way before the store and after the factory. And the big change from all of this that really matters is that EPCs, and an EPC is the number that's on an RFID tag, it allows for individual item tracking. There's a system that the world revolves around now, especially when it comes to supply chain, which is quantity accounting. You can think of it in terms of I am buying 10 apples. Well, here are 10 apples that are being shipped to me. If I wanted a receipt or a bill of lading, it would say apples times 10. That is quantity accounting. We're identifying the type of item and we're identifying the total number of items, but we're not necessarily identifying this is apple number 1, this is apple number 2, this is apple number 3, this is apple number 4. It takes much less data to use quantity accounting, but we get much less specific visibility to the item. In the world of RFID, we're moving to individual item tracking. So what that means is that every single apple would have its own unique serial number. All of the items that we send through the supply chain have their own unique serial number, which requires a little bit more responsibility because we're sending much more data. But the good part about that is when we have much more specific serialized data, it allows us to do things more safely and efficiently. So if someone does get sick later, we're able to trace back that specific apple that they purchased all the way to the source. We know exactly where it came from. We know exactly where it went. If we need to do things like product recalls, we can do it almost instantaneously. If there are any problems in the supply chain, we can identify where they happened and make sure that they didn't happen again. If we have some efficiency needs that we need to overcome, we can go back through and trace these things and get there. And then for you as a consumer, it can help you guarantee that the items you're getting are the items that you purchased. So it's not a counterfeit item or a knockoff item, which is annoying when you're buying something like a pair of sunglasses or a pair of expensive shoes, but it could be deadly if you're talking about things like medication and drugs or even food that is not what you thought it was or is counterfeit, and it may be unsafe. So this move from the supply chain from quantity accounting to item level tracking is going to happen everywhere all around you in the next few years, and it's going to have a lot of broad impact. So in the world of retail apparel, a little bit of the history of RFID. In late 2008 till now, we've seen a lot of retailers adopt RFID. Dillard's, American Apparel, Macy's, Target, Amazon's done some things, Walmart, Bloomingdale's, JCPenney, Saks, etc. Lots and lots of different retailers that have experimented with RFID or have moved into adoption of RFID on apparel. Since 2015, there have been approximately 4 billion items RFID tagged. In the year 2015, there were approximately 4 billion items RFID tagged for the U.S. In 2018, there are approximately 8 billion RFID tagged items in the U.S., so that's doubled in the last 3 years. We're expecting that curve to continue to increase. The scale and the pace of adoption are very widespread. It would be hard for you to probably go out and buy apparel today in a store location that doesn't have some type of an RFID tag on it. You have probably purchased many items with RFID tags in the past, and maybe not even have realized it, but you can look for that EPC symbol to find it. Again, we talked about the tag samples before. Those are the different types of tags that you would see on those items in the store. The tags come in a few different flavors. Passive, semi-passive. That tag in the middle there is a semi-passive tag that is actually has a battery on board that helps with temperature censoring or whatever it may be. And then active tags down here at the bottom. These actually have a battery on them and they transmit. Most of what we are dealing with today, especially in retail apparel, is the passive tags up here at the top. The active tags are more for asset tracking and control. These are the readers that we talked about earlier. You may see these in different areas. These are about the size of a laptop, and there are different ones available on the market. We've also looked in the past at forklift mount readers. These would actually mount to a forklift or a fork truck so that we can scan items as we're carrying them through a space. Different types of handhelds, again, as we showed you earlier. These are frequently seen out in stores or in warehouse environments. The read zones, we talked about dock doors earlier and showed a little bit of this. We're scanning items as they're moving in and out of a transition point like a dock door. Conveyor systems, frequently you see RFID scanners on conveyor lines. These are scanning items as they're coming down a conveyor and scanning things in the case to make sure that the cases are complete. And then we look at combinations of how these work. So what type of readers we're using, whether they're mobile or static, also depends on whether the things that we're scanning are mobile or static. So we may use static shelf scanners to scan the items that are on the shelf versus a forklift has a mobile reader and the items that it's scanning are moving around the area as well. So if you have an RFID application that you're thinking of, try to understand where your items are going to be moving or they're going to be stationary, and then try to select your RFID read system to determine whether you're going to read those items in a point when they're static or when you're going to be carrying that RFID reader around to scan the items. In a generic distribution center, and this is a very basic illustration, a lot of times we would be looking at RFID on the receiving side, so on the receiving doors. We may use conveyor readers throughout the facility to scan those items as they go down the conveyor line so that we know what the cases and the items are that we're receiving. We can use that for put away or for picking and packing. And then finally scanning those items again on the shipping doors before they actually leave the facility. In a store itself, we may scan the items at the receiving doors when they're scanned. We may have backroom readers in the backroom area where we can scan those items as they're on the shelves, either overhead readers or handhelds or whatever it may be. Sales floor transition portals. We've seen a lot of stores set up where we have RFID readers on the transition doors between the front room and the back room of the sales floor itself. And then out on the sales floor, we typically use a lot of handhelds and things like that. We've also seen stores use RFID at the trash, so at the box crusher or at the trash at the exit, so that way we can monitor things that are spoiled or damaged or destroyed and take them out of inventory because we wouldn't expect to see those at the point of sale. So you wouldn't want your inventory system to think that a damaged item is still sitting on the shelf and available to purchase when it's been thrown away. RFID data, this may look a little bit of intense, but this is one RFID item. This is the EPC number for that item, and we're following it through the supply chain. So what we start at the DC, we have a date and a time when we saw it. See it inbound at the DC. We then see it move over to conveyor line and then back outbound from that distribution center. From the store DC, we see it kind of inbound, the store itself inbound to the store. And then we see it over in the back room not too long after that. And then maybe 1 or 2 days later, we would see it go out to the sales floor. We may see it come back from the sales floor a little short time after that. That typically means that the item was stocked onto the shelf, and then the case itself comes back into the back room and goes to the box crusher, and we know those items are on the shelf in the store. RFID for sustainability and recycling. This is something that's been discussed widely and has been implemented to a smaller extent. The idea is that if we have RFID tags on items, we can identify whether those items are recyclable or not whenever we throw them away. This would help us with monitoring throws and trash. You know, a lot of people think of recycling in terms of it's good for the planet or it's an ethical thing to do or whatever it may be. But the economic reality of recycling and sustainability is that it's a positive cash flow. When I recycle things, I can get paid for them. When I recycle cardboard or aluminum or whatever, that's cash that I can bring back to me. It may not be very much, but it's a little bit. When I throw things away, most cities have to pay to take that to a landfill. You have to pay someone to take your trash away. So every item that you take out of the trash, which you have to pay someone to take away from you, and you put into the recycling, which you get paid for, is a economic benefit. You're reducing a cost, and at the same time you're increasing a revenue. So if we can use RFID to scan those items that we are throwing away and identify when we're consistently throwing away recyclable materials, or maybe even automatically resort recyclable materials, it's not just an ethical win, it's also an economic win for those users. Aviation, there's a lot we've got going on with RFID in aviation. There are some things that are happening with scanning parts for maintenance history, and then there's also a lot for RFID in aviation with scanning for safety equipment compliance in the cabin itself. Food safety is another thing. In this slide, what we're showing you here is some data that we did many years ago. This is with some bananas that we were receiving in a pallet. And the reefer truck that we see over on the right, that's the refrigerated cold truck. All of these pallets on here, we had a temperature monitoring RFID tags on them. And then what we did is we monitored that temperature and shipment as they moved through the supply chain. And we were trying to see if the airflow was continuously circulating through this truck and if all of the bananas in this truck stayed within the acceptable temperature level. So you can see the container set point was down here, but a lot of the items went over that set point because things happened during transit and shipping. And then two pallets in particular went much higher. Was you notice they're right here back by the doors in the rear of the truck, which makes sense because when you open the doors, then the colder air gets out. So we're looking at a bit different and better ways to monitor temperature through the supply chain per item, per pallet, per case. And we can do that now with RFID, and depending on the product type, it can have a tremendous benefit. Athletics, we talked about this a little bit earlier, but this is an RFID tag on a player for the NFL, and you can see some of how these players or how the league is using player tracking out there on some videos. The robotics and drone team. So at the university, we have several students that are working to develop automated inventory robots and drones. Here you can see Dr. John Zhang and Johnny Five. Johnny Five is a robot that he and his team put together that actually goes out and drives itself throughout an area and does an inventory scan and inventory control. In this case, it's doing an automated scan of a retail store environment. If you're interested in robots and drones, we encourage you to come out and take a visit, and we'll be happy to show you what we have. Another thing that we do to help support the industry is what we call the ARC program. It's an RFID testing and grading program. So what we do is because there are different types of RFID tags available, many people aren't sure what kind of RFID tags to use in their particular application or environment. So we encourage people to go out and do what we call a pre-pilot. It's investigating the environment where these tagged items are going to be scanned, whether it's a warehouse or a retail store or an airplane or whatever it may be. We can test and grade that environment. We provide a grade to that environment that says this is the level of performance that an RFID tag or an RFID tagged item needs to meet in that space. The second step is benchmarking those RFID tagged items. We have a giant anechoic chamber at the lab. This is a specialized testing chamber where we can put tagged items in there and scan them to ensure that they're scanning at a proper read capability. And then finally, we can go out there and validate that in the store environment. We do audits and things to validate that what we're saying is the truth. So that pre-pilot, that benchmarking, and that validation process, most of the retailers in the U.S. use the ARC program for this validation program. Essentially what it does is, because there are tens of new types of RFID tags released each year, they don't want to have to go out and test each new RFID tag on apparel in the store every time a new one is released. So with the ARC program, we can give them a little bit of information about what they should be seeing in terms of RF performance from new tags before they have to field test them. This helps make things a lot smoother. It makes them make better decisions on the types of RFID tags we're purchasing for the items. And it also helps to tag and inlay developers because they know some targets and goals that they need to develop towards for new tags and models. Finally, in terms of regional impact, Tyco and Johnson Controls, we actually has a staff member that's permanently stationed here in Auburn at the lab that works alongside the students. We welcome that, and we have many of our other companies that we work with that have sent people down here for extended stays for months or even longer that would work with the team on projects. And that's good because that brings that external technology community to the Auburn area. We have support for startups and entrepreneurship. We have several student concepts that have come through the lab where they're looking at putting together some type of RFID solutions for their own companies. And we do tours and visitations. Over 1,000 visitors each year. Actually, we hover at about 1,200 to 1,300 visitors per year typically. We do lab tours almost every day. This is from small groups of just a few people to large groups of 50 to 100 people sometimes. That helps bring people to the Auburn area, to the university, and gives them some exposure to campus. And about 90% of this lab funding comes from out of state or internationally. The lab is soft funding, meaning that we bring in much more funding to the university than a traditional unit because we are actually getting these external partners to fund this. Everything at the lab, including the students, the staff, the faculty, the equipment, and everything is completely funded by external partners who value the research that Auburn University is doing. And of all of that external funding, over 90% of it comes from out of state or internationally. We have some international sponsors. Most of the sponsors or companies we work with are outside the state of Alabama too. So what that means is that we're bringing money into the state, especially technology money, into the university, which helps with Alabama and the local area as well. If you have any other questions or comments, I encourage you to contact me. My name is Justin Patton. My contact information is here on the screen. I'm the director of the RFID Lab. If you're interested in coming to visit, we'd be happy to set up some type of a tour or something as well. Thank you very much, and we hope to see you soon.